All right. This is version control for beginners, a gentle introduction to version control for FreeCAD using the History Workbench. Quick intro, my name is Effie Blanchet. I live in the beautiful mountains here of East Tennessee, so sure do appreciate y'all coming out here to great state Tennessee. So it's a beautiful place. And yeah, my main background is in software engineering, and as of the beginning of this year, I've gone full-time into a startup with my father, making our electric propulsion system. And we're very big, both of us, on privacy and open source, everything that FreeCAD stands for. And I'm happy to say that as of about 3 years ago, we dropped all our commercial CAD licenses, and we're all full in on FreeCAD. So big thank you. Big thank you. So yeah, so the first part is just going to be going through some basic concepts for those of you here or on the stream that are not developers and are new to version control or have heard about Git. They don't really know what it is. And then after that, we'll just go into a live demo to see how it can be used within FreeCAD. And we'll go from there. So this is what I call the versioning Stone Age. Everybody has done this at some point. You create typically backups, different copies of stuff. You call it, bracket V1. And you're going to have a bracket V1 dash final because certainly that's going to be the final one. You have a final 2 that maybe is manufactured, MFG, right? And then you would have a dash final copy. Why that is a copy, why that's there, you don't know, but it's there, so it must be important, right? And so on and so forth. So we've all done this, and to be honest, I still do this if there's something very, very simple. You don't need any kind of crazy tooling. So it's important to understand the problems with this because, to be honest, before, even when I was a developer many years ago, before using Git, I was also thinking like, why do I need this? No, I can just whatever. I can FTP my code up to my server. Whatever. I can figure it out. But I feel like it's one of those things where if you've never used it, once you use it, you never want to not use it. And you want to use it for everything that's possible. So the main problem is that poor change tracking, right? You don't know what changed, you don't know why it changed, and you don't know when it changed, right? So you may say, oh, I got my timestamps on my files, but you try to move something from from your computer to your hard drive, and all of a sudden all your timestamps are gone, right? You can't easily compare with you can't compare the different versions. It's difficult and time consuming to roll back to a previous one because you have to first identify what is the correct previous one and which parts are the correct ones that I have to revert to, right? Excessive duplication, you copy the whole folder, that takes a lot of space, especially for binary or FreeCAD files or whatever. Difficulties with collaboration, right? It's not even a non-starter, just folders. And of course, more prone to human error, right? You start getting a lot of folders, you might say, hey, I don't need this one, I'm just going to delete it, and things kind of fall apart. So version control actually solves all of those problems and more, right? It's a system that records changes to files over time, allowing you to review history, compare revisions, and restore earlier versions. You can consider it like a digital undo button for your entire project history, and it's a lot more powerful. And it gives ultimate peace of mind. Very, very important. For me, that's very, very important. And I would say if there's like one reason that I say you have to do this is you need peace of mind. And besides the benefits of solving the problems that I had already mentioned, there's other things that because of how easy the tooling allows you to create versions, you naturally will create more of them, right? So you'll have more to kind of fall back to and see what has changed along the way. It gives you more freedom to experiment more easily. It allows you to document your intent more clearly in the messages. Scalability, you can start by yourself. Maybe you're wanting to do a startup, but you can then continue using the same tooling for once you have a team. Another thing, AI, it's AI ready. Brad mentioned on the last one where, now you got to already start thinking, we're going to be having tools that let you create CAD, things for you. And it's a reality. It's controversial, but it's already starting to happen. In fact, on the last developer meeting. I don't remember who said it. Maybe it was Brad or John or somebody that, they had a use case where they just needed to go in and just like double the size of everything. So they just go in and tell the AI, hey, just double the size and make everything double, right? So, but how do you make sure that it actually does the thing that you said it does, right? So it can double the size of everything, but you probably don't want it to double your angles, right? And there's various things. How do you notice that? Like, if you double an angle from 4 degrees to 8 degrees, well, you might not notice that visually if you're just looking at something directly, right? So you need to have the tools that tell you exactly what has changed. And did I mention it gives you peace of mind? It's very, very important. Look, we all want world peace. That starts with individual peace of mind here, so use version control. So the History Workbench, and I wrote this workbench earlier this year to scratch my own itch in the hopes that this would be helpful for others as well. It is backed by Git, but do not worry if you're not a developer. You do not have to understand it. That was one of the main things that I really wanted to focus on, is that to make something very intuitive and not riddled with complicated terminology, because I've seen people just kind of step back, like, they think Git and they think like terminal commands in the matrix and stuff like that, So I intentionally made the decision to switch the terminology to something that's just regular, that anybody can understand. But when I explain these concepts, I will put the equivalent Git concept in blue, so you can see that. And so now we'll just a few basic concepts for version control, and then we'll just jump right into a demo after that. So the first thing is, of course, the project or repository in Git is the complete track project with all your part files and the entire history of every change that has ever been made. And all that is stored within your directory. It's not some kind of hidden thing in some database in some server. It's all just directly on your file system on your computer in a little .git folder. So just do not delete that. It looks like it shouldn't be there, but that's where all your history is. And you're not going to be able to understand what's in there. It's a special format, but it is, in a way, universal. So just do not delete it, please. Next thing, iteration or commit in Git. So this is a permanent named save point for your entire project at a moment in time. You can consider it kind of like your snapshot of, this is my project right now. And you can make as many of these as you want. Right? So each iteration will record the changes, of course. The author, if you're working on multiple with other people, it'll have the date and time and a descriptive message that explains the what and the why, and it'll have a unique ID for that specific iteration. And you can always return to it no matter what happens later. This is kind of a very important thing, that it is not possible to change your history. Right? Once you create your iteration, that's it. It's set in stone. There are tools, if you're more experienced, there are ways to change the history, but if you're a beginner getting into this, don't even try. It is error prone, because if you try and change your history and you mess something up, well, you've messed up your history, right? So the Workbench does not allow you to change the history once you've created it. But I guess it is worth mentioning that because it is backed by Git, you can do whatever you want. Since it is Git, you can use other clients. All right, the next concept is the current files. That's the working tree. It's your actual files that this is actually your live working copy that you're working with. That's what you're familiar with already. And each file is tracked by the Workbench. It's either unchanged, it's modified, it's an added file, it's a deleted file. And the Workbench compares the current files against the last iteration, or if you have any reviewed files. So pretty straightforward. You'll see how that looks like shortly. And what is the reviewed files? There's something called a reviewed area. It's an intermediate zone where you select and prepare exactly which changes will go into your next saved iteration, right? So you may make a few changes. Say you're working on a feature. And you say you review them, and you say, you know what, this looks good. You click the reviewed button, and it's going to go into the special area saying, I've already reviewed this. I don't need to necessarily review this part again. Okay? And this enables precision. You choose exactly which files you want to be stored in the next iteration. And it also enables a review loop before saving each new iteration. So it kind of looks a little bit like this. So you have your current files, you're working on them. You go into the workbench, you review everything. This looks good. You set them as reviewed, and they go into your reviewed area. You consider this kind of like a copy. You take the current file that you have, you just make a copy of it and say, I've reviewed this. It's exact copy. It stays there. And then from there, you can choose to continue doing some more work, right? You might add an additional little feature here and there that you're building up to. And then you review it again. And then once you're finally accumulated enough, then you save everything and say, hey, this is saved. And each iteration is fairly cheap to store. You know, it doesn't take too much space, so you can make as many iterations as you want, really. There's no rules about that. So let's just jump into the demo here and see how all this comes together, see how this makes sense. And I'm sorry for not using dark mode. There are some people that get angry about that, but I figured it's better for a demonstration. It's a little easier to see, I think. So you'll have to forgive me. So this is this model here is a coupler that goes into a diesel engine. I did not make it. A Serbian by the name of Mr. Jan made this, but this is a good, just typical project of decent complexity that can warrant, using version control. It's got multiple part files. It's typically good practice. Each part is a single file, and they all come together in a single assembly, right? So we have a project here that we're already starting with. So we're going to go over to the History Workbench, and you'll see no project detected. We haven't actually created it. We have a bunch of files, but we have not yet started our project or the tracking yet. So we're just going to go in and hit Initialize a Project, or from the History toolbar, Initialize Project. And it'll choose a directory to initialize based on current open documents. So it sees that we already have some open documents, so this is the folder that I want to initialize it, and that's it. So we're in here. Now we're going to go to the current files area. We're going to click this. And as you can see, we have a lot of every single file which is open here on the left. We have listed here, and it's all green, means it's new. It's a new file because we don't have any history for it yet, right? So everything is green. That makes sense. Yeah. So the very first thing that we want to do if you have an existing project is you want to create the first initial iteration. Right, and to do that, first we're just going to say mark all reviewed, and that's going to put it all into this reviewed area. Right, if we click it, we're just going to see the exact same thing here. And however, I intentionally missed one important thing, and that is whenever you're saving anything, everything has to be recomputed. All the documents have to be recomputed so that the values, expressions are all evaluated properly. So I'm just going to hit this button first, recompute all. It just recomputes all of the open documents. And then I'm going to refresh the project. And in this case, nothing actually came up, which is good. But something will come up later, which we'll see. So now let's start making some changes, right? So the first thing is, let's say we're going to go in and just maybe change the spacing of these holes. All right, so we're going to click into here. Why isn't this opening? Here we go. Let's go to the link object. So here we have some holes. I'm just going to change these, let's say, from 30 to 25. And it looks like hopefully it changed, right? So let's go back into our assembly. Everything we're going to recompute. And let's go to our History Workbench. Let's click that refresh button. All right. So we have some changes here. So we can see right away that this file here is blue. It's modified. We have a sketch, and it looks like our constraint has changed. So in this case, we see that one of the constraints, or two of them rather, have changed their value from 0.52 to 0.54, which actually looks a little bit weird until you realize that the angles are stored in radians, not degrees. So actually this would be a nice feature for me to add in here, to put a little parentheses here just to put the degree, the value in degrees here. So we can confirm that this change here actually looks good. And if we go into the body, we can just click the diff view to see the whole body, the 3D diff view. So give it it needs a couple of moments to essentially do a Boolean cut to figure out what has changed. And soon, I believe this is going to be fixed in the next release, where every compute is actually going to be in the background. So that's what Chris was talking about. Awesome. So we can see that indeed we see some changes here. So the red stuff is the material which has been removed, right? So we actually shifted the holes. The hole that was here shifted over in here. So the green means the material was added, and this material was removed. So we can go in and remove whatever things we want, just leave the added material. We can also just take a look at what did the new one look like compared to the old one right away if we want to. It's very useful. And so we took a look at this and like, all right, this looks good right here. So I'm going to click that reviewed button. So remember that reviewed essentially makes a copy of what we just saw, and it saves it into this reviewed area. So you don't see that same file here anymore. It was actually removed, not because it was deleted or anything like that, but because we made the copy and it's now in the reviewed area, it's now doing a comparison between the current file and the reviewed file. And because they're exactly the same, it's saying, hey, there's nothing different here, right? Which is exactly what we want. And here, now you'll see we actually have some differences in the assembly. And you'll see, for example, that some faces changed in the assembly. Before it was face 151, now it's 140. And we'll see some similar things here where actually the rotation of the joint in the assembly has changed. And the reason that is showing up is because I found out that the joint solver is currently undeterministic. So sometimes, you can say put a part like this, but it's also equivalent just if you rotate it in a certain in a certain way and you change the axis, it works this way as well. So it's not really fair to say it's a bug. It's not a bug, but it's just undeterministic. So I will go in and put in a GitHub issue to say, hey, maybe we can make this deterministic, and therefore there won't be any diffs that will come up in the assembly workbench whenever you regenerate. So we're not making any changes anyway to the assembly here, so we're just going to ignore that for now. So another useful thing is that if you make a mistake, it's very easy to restore. That's another thing that this workbench allows you to do. It allows you to restore a file that was either reviewed or iteration. And I think we can go into some sample thing where, let's go into the assembly actually. And let's say, for example, that if we hide this one, you see there's a hole, and it looks like this screw or this bolt is a little bit too big. So we need to make this hole bigger. This is just another example here. So I'm going to go into here. Actually, I forgot I have a master var set in a separate file. This is a very kind of realistic use case. It's a common, or it is a method of top-down design where you have one file like a spreadsheet or a var set, and you make a change in one variable, and it propagates through many of the different parts. So I have here a bolt hole diameter. All right, 19.5. And let's say, okay, we need to increase a little bit. I'm just going to make it, I don't know, 23. All right. I'm going to go into here, refresh, and you can see now actually that looks pretty good. The whole model here looks pretty good as well. Nothing seems to have broken in terms of the assembly or anything like that. So under normal circumstances, I would look at this and say, hey, you know what, this is good. I'm just going to go ahead and, maybe I'd send it off to manufacturing or whatnot. So I'm going to go into the History Workbench first and do a quick review. All right. So that's one of those things that even in you're working on something very simple. It's the same in programming. It's the same in CAD design and anything. You can make a very, very simple change that you think, why do I need to review this? This is stupid. Why am I wasting time? And it has bit me so many times that I have actually made a rule that I make a one-line change in programming or I make a tiny change in the CAD model, I have to review it because there might be something that you don't understand that happened, right? So in our case here, we have a sketch. Or no, sorry, it was this hole that I changed here, right? So we can see, okay, it changed from 19.5 millimeters and now it's 23 millimeters. Okay, that's perfect. But there also appears to be, of course, we have our var set change as well. Oops, 19.5. But something else has changed here. Another file here. Why did it change? 9.75. This one changed to 11.5. And now I see, oh, well, we have an expression on this constraint, and this expression is also set to use this bolt hole diameter, just divided by 2. How did that get there? Whoops. So I actually did not intend to do that, but that is something that you look at your assembly and you would not actually recognize. And in fact, if I were to go in here and look at it, there is actually a bit of a space here that should not be there and would have been impossible to really see that visually. So that's pretty much what what version control allows you to do. You can go in and hit your reviewed button, say, okay, I want this. Actually, in that case, I didn't want that. But I can say, okay, that was a mistake. I can go in and I can solve it. I can change that to be a different expression. I don't need to do that right now, but I think you guys get the gist. So now we're in our reviewed area. Oh, and I forgot to make the commit. I am a bad demonstrator. Sorry, guys. I was supposed to make a first commit here. So you click this button, save iteration. I'm going to call it initial save, whatever. And you can put as much stuff as you want here. A typical good practice is kind of a short first line description. And then on the second paragraph, you can do whatever, a bunch of changes, 1 and then 2, and then do as much as you'd like, right? So when you click OK, so we have our iteration. It's saved here on the left. And if you hover over the iteration, you'll see the full message that you typed there, right? That's pretty much it in a nutshell. Another use case is those kind of mistakes where you accidentally go in and you make a change that is a mistake and you didn't realize it, but you already hit Control S and it's already saved. You guys know what I'm talking about. It's saved, and now shoot, your last backup may have been done a while ago, right? So with this, if you're reviewing, you have a bunch of last iterations, it's super simple to go in and change things. So I'll just do a really quick change here. For example, I'll go into this part again, and I will change the linked object. And let's just say we'll go in and change this revolution. And let's just say on purpose we're going to break something by accident, right? That doesn't make sense. But now we have an error. Whoops. Okay. So I'm going to go in and I'm going to fix it. I'm going to put it back like this. And a chamfer is still broken. I think I can revert it back to exactly the way it was, but something still gets broken. I can go in, I can fix that chamfer, and then maybe something else down the line is broken. So things just get broken. Well, all right, not a big problem. We'll just go to we can first see the change that we have here. We can see the sketch has changed. So let's just go to our last iteration, and let's just go to that file, 8. Click the restore button. So this operation will overwrite the current file on disk with the selected saved copy. This is the only operation in the Workbench currently that actually changes your FreeCAD files. It was very important to design this, in my opinion, in a way where your files are never going to be touched on disk. There's nothing happening within this Workbench that's going to tweak or add information about your files, about what has changed, nothing like that. So your files are always preserved, but whenever something does change, it's very clear. You should see these pop-up messages like that. Now, all of these files here currently open, they will be closed. And the reason for that is because if you have a project where you have dependencies between different files, we just want to make sure that all the links and dependencies are all updated, right? And so to do that, we just go ahead and it'll stop that. It'll close everything and restore that file. And then once we go in here, we see no more errors. Everything's back the way that it was. And that is it. So that's it in a nutshell. I'll be happy to answer any questions if there are any.
You have a model that has like a really deep history.
Yes. Oh, do I have one?
Yeah.
I don't have anything that I can show right now, unfortunately. Yeah.
You mentioned a .git directory.
Yes.
Does that mean all your version control is happening on your local machine, or is it actually going to a Git repository?
Great question. Okay, so the question is does everything stay within the Git repository locally, or does something go out to a server? So something's glitching here for me. I don't know if you guys see that.
If I have a local Git repository, I'm running my own home server, can I add this, just upload the files to that?
Yes, so the question is, can we also just upload them to a remote Git? So it was in the spirit of kind of privacy and open source, everything was designed to be local first. So it just only creates the Git repository locally. And if we look at the project directory here, you will see this .git directory that I mentioned in the beginning. And there, by the way, I'll also mention there is a .snapshots directory that's related to how it stores the information about the files. So make sure not to delete that or touch these. These are hidden files. You see the period in front of them. So you might not even see them if you have hidden files disabled. But the History Workbench functionality does not currently have the ability to add an external, a remote repository. And that's something that could be, I think, actually added pretty simply. But collaboration features haven't been implemented yet. So, but you're welcome to host the Git repository wherever you want, on GitHub or on your own server, and just use the command line or some other utility to do that. Again, you can do anything you want that you would otherwise do with Git.
Part of the advantage of using Git and a repo off-site is that my hard drive crashes.
Exactly. It's a better backup,
Yeah, I get the backup.
Yes. So actually, I think that'd be a pretty good feature to add pretty soon. And of course, it would always remain optional. It's not like you're starting. You're always working on a remote. There's definitely a good use case, especially for companies, that they need a PDM or a PLM software that everything's kind of centrally managed, But also once you start going into that, there's also like how to do merges and things like that, maybe someday. Someday. Yes?
I'm a little confused at what level this is working at. So like a normal FreeCAD file is not ASCII, is it? I mean, I don't think it is.
Yeah, so the question is on what level is it generating the diffs? Is that?
Yeah, because you showed the file there where the whole like a normal div, but like that detail is not.
Yes.
How did you get that detail?
Yeah, so the question is how the level of detail was created here. And the answer is that technically all of the actual properties are actually stored in the FreeCAD file called the document.xml. So there is an XML file that has this information, but I opted not to use that for a couple of different reasons. One of which is that unfortunately that file does not allow you to have a full tree representation. There's no way to recreate this tree that for me was one of the top priorities. because I'm looking at my tree all day, and I want to be able to see the diffs the way I'm used to seeing them, right? Now, underneath the hood, on a low level, there actually is no tree. It's just, there's just references between different objects. Everything is just one level. So I said, you know what, I want to have a tree, so I have to create some sort of separate file that stores the state of a particular FreeCAD file, right? So I did that.
So you're writing inside the workbench, you're writing an external file, and then it's the
You're right, right. So on the low level, it actually generates a YAML file, and you can even use this and diff them in another, text diff manner, and you'll see what it is there. But it is essentially a YAML file with all the current properties and everything that's there. But it also stores the state of the tree. And another minor thing, but also a kind of a nice to have, is that these properties are grouped the way that you're used to seeing them grouped, right? So it's especially pertinent if you look at just whatever, just like say a sketch, right? You have an attachment, you have a base, internal geometry sketch, and so I extracted that, and it's like storing metadata essentially, and that is committed along with your iteration, right? In a way, I was also kind of hoping that wouldn't come up, because I actually want to change that. It might change a little bit, because I think a better design would actually be to just rely on the document.xml as the source of truth only, and go to it every single time, and then just to only have the GUI related stuff for the tree stored separately, unless we are able to get that, like put that into the actual like GUI document.xml, which is there, in which case I have all the information I need without having to store anything separate. And in fact, there is a discussion going on right now with Peter, how do I pronounce the last name? Peter Hema, where he was also working on some kind of diff project. And he saw my project, this workbench, and he said, you know what, maybe we can even make a way to expose some of the functionality that you need, so that you don't have to kind of maintain it yourself in this workbench. And of course, there's a lot of other workbenches like on-cell lens and other things that could make use of diffing or whatever functionality, right? So it seems that he thought it made sense. So maybe the developers will expose, the tree, actual tree, and other things, property groups, and then there will be no need to store anything else. Yes.
How do you handle, so like, I understand like if you're rolling back to a point in time, and effectively like how that could always work. But what if you're trying to effectively revert the commit, and then that commit would otherwise conflict with that reversion would otherwise conflict with the current point in time on it? Like, how would you merge conflict?
Well, when you, so the question is like, what happens if you're revert or restore a file from the previous iteration, and then you go and it creates some kind of a conflict, perhaps with other files?
Well,
is that?
like the current, so like for example, if I added an arm or whatever, and then I had it come back and like intersect itself, but then I removed the face that it was on later on.
Okay.
And then I try and remove that arm feature from that point in the history. Like it seems
I
like
see.
that would cause some merge conflicts. Which
Right.
is the same thing that happens with just normal text-based code.
Yes, yes.
You need a merge editor.
Yes. So basically, when it comes to reverting features, that is not supported. You cannot revert a feature. It's the whole file or nothing else. So on the file level is, I think it's really the only realistic way to do it, unless Chris, somebody smarter than me, can say, yeah, he's like, Chris is like, no way. Yeah, yeah. Oh, it would be a lot of work to do like merge kind of thing. Now I know there is another CAD software that does it, so I know that it is possible. But yeah, that's a whole different ballgame.
I mean, just normal like code merge errors are like analogous to the top of making problems.
Yeah.
Right? Like if you're changing the architecture of the file too much, then
Yeah.
the topology is different.
Yeah. On the other hand, history, we're kind of used to doing things where you have to go back and you change history, and sometimes it just breaks. You have to take care of it, right? So I do see maybe a way where you can just kind of takes a new feature or something, and that is missing in the, or new in the other one, and stick it in there, and maybe it doesn't break anything. Or maybe it does, and you have to fix it, but either way, you were able to kind of merge that in. So maybe there's a way. Yeah?
Does it work with CAM Workbench yet?
So I've tested this on Sketcher, Part Design, Part, and Tech Draw. I did not test this with CAM Workbench or other Workbench, but in theory, everything should work. There might be certain things which are not very useful, perhaps to look at. Like, for example, when I was working on Tech Draw, I kept getting changes every single time related to some kind of a cache template. There was a cached thing that was constantly being changed. So there's actually, that actually kind of brings in a good extra little thing to add here, is that if you go into the settings of the History Workbench, you can actually choose which properties or objects you want to exclude. So if something is like not helpful, or it's useless, right? You can just go ahead and add that particular object into this list, and it won't show up in the diff anymore, right? So it is kind of made so that kind of to be generic, so you can use this with hopefully any kind of workbench. And you can also note that if you hover over any particular object, it'll show you the name of the internal object type. So you'll see that this one is a Part Design pad. So if I were insane, I would just go in and add that to the list. Right. Yes.
Unlike code, CAD's very visual, shape oriented. It'd be very cool if when you make your commit, you could attach your thumbnail, and then the user could browse the history by looking at the shapes.
Yes.
Yes.
Yeah. So.
I thought the diff was brilliant. That's really cool.
Yeah, so the question is about thumbnails, maybe to be able to include that. I actually had that feature request before, but I think FreeCAD already includes a thumbnail, or optionally in the settings you can include a thumbnail, so it would just be a matter of extracting it, right? So I think that could be done very easily, actually, yeah.
And you may want to make it optional. The user could include the diff as the thumbnail for the commit, like your red green, so you can see what changed.
Are you talking about within this view that we see here?
Well, when you make a commit message.
Oh.
Attach an image to, so I'm browsing through the commit history, I can see, oh, this is the one that moved the holes.
Yeah, that's a great idea. Yeah, to be able to attach a thumbnail to the actual commit, so that when you're in your iteration list here, there'll be a little icon there. Yeah, that's a great idea.
One last comment on the red and green. Was that your choice of highlight colors?
Yes.
Let me mention that all men lose red-green color distinction as they get older.
I see.
I found out after my first presentation to my boss's boss, red-green, you couldn't see it. Yeah.
I see. Okay, so switch from blue-green to something that is more accessible. What's that?
Thank you, configure real good.
Yeah. Yeah.
It's open source, just add an option.
Yeah.
Add an option, man, add an option.
Right. Yeah.
So I think this might have been answered in Mark earlier, but when you make a new version, a new commit, a new iteration of each project, does it basically store a new copy of the FreeCAD file, or it looked like it didn't? It looked like it just did a YAML file instead, or does it do both, or how does that? Does every new iteration become a new FreeCAD file sitting on your disk somewhere?
So the question is, does every iteration that you save, does it copy the existing files as they are? Git has its own way of storing just the differences that are part of every file. It does not store the whole copy, so it's actually more efficient than copying the whole file. However, there's a caveat, which is that by default, FreeCAD has compression enabled, which means that every file is a binary file technically, so if you go in and change one tiny little thing, or even just press Control-Save and the timestamp changes, the whole file is different, which makes it not efficient in terms of storage. But if you go into Edit, Preferences, and you go to Document, you can go to this document compression level and you can set that to 0. That's kind of a little trick that I saw online that a number of people are using, where you set the compression to 0, and because so much of the source is XML based, not all of it, but it's XML based, not everything is going to change within that file. So it's only going to change it's only going to store kind of the differences between the last files, right? And the snapshot that you saw, the YAML file, will also just change within there. So it's not going to change the whole file. It's not going to like store the whole copy. And Git has its own internal mechanisms of saying, just give me the whole file as it was at this particular iteration, and it can recreate that whole file. And that's exactly what happens when we hit that restore button. It just says, I just say, Git, please give me that file. I say, thank you, and now put it here. Overwrite that file, right? And that's it.
But that only works with the compression on the finished file set to 0.
It'll always work. You can use this workbench without that setting. Setting the compression level to 0 simply saves some disk space so that it doesn't have to copy the whole file every single time you create an iteration, if that makes sense. It's just a disk saving thing.
So it's a trade-off on saving, you're taking up more disk space at that
Yes.
point for just the most recent file.
Yes.
Less disk space in the total of your recent file plus your previous iterations.
Exactly. So you will use a little bit more disk space for each file the first time around, or for your current files list for your just active directory. And then after that, they will take some less space. And there are some projects out there that I noticed that they're trying to save on space. There's one called like Git SCM or something like that. I forgot the name of it. That does some kind of kung fu in the back to empty the whole FCSTD file and then just store them separately somewhere and kind of save on space. It's just a matter of personal preference. Personally, for me, I don't really care that much about space, so I would prefer just not to touch the FreeCAD file and just, let the developers deal with it. Chris, that's on you. Brad, that's on you, right? You guys take care of that, and I don't want to mess with it. Disk has been getting so cheap over the years that you can get a terabyte or two for nothing these days. So I don't even think about it too much. Yeah, but yeah, that's just personal preference. All right, thank you.
Have you had any contact with the Opulo folks?
I don't know who that is. Opulo?
Opulo, to make an open source pick and place machine.
A what machine?
Pick and place for making circuit boards.
Oh.
Marshall, Stephen Hawes, YouTuber, he started the company. They were pushing FreeCAD plus a Git-based version control thing, harder than anybody I've seen. They became very useful. It's not really great.
Because of the way it aligns.
All right. I've been asked by a couple of people to make sure that I highlight the fact that our meetings are open. There's a calendar out there at freecad.org/events. We're doing all of these maintainer meetings that Brad mentioned. You don't have to be a maintainer to show up at those meetings. Anybody can show up at those meetings. We certainly encourage developers to show up at them. So freecad.org/events is going to show you our meetings calendar. It's going to show it in your time zone, so it's showing me the times right now, just in U.S. Eastern time zone. But I should call your attention to the fact that Effie, his work on the History Workbench, it's an add-on, and we have hundreds of add-ons to FreeCAD, and there is a bi-weekly add-on developers meetup that dedicated specifically to add-on developers. It's run by Frank Sarko, or however many letters he has in that GitHub handle. Anyway, Frank runs that meeting, and so that's this what's showing up here as 10 a.m. on, it's every other Tuesday, I think. But as you can see, there's a CAM meetup every week. If you're one of those crazies, we have an Open Cascade meeting, and that is with Dimitri, the Open Cascade developer, and again, open to anybody who wants to. We have our bi-weekly, or twice monthly, I should say. So our twice monthly developers meetings, that's not specific to any particular, like we're not trying to merge PRs or anything like that. That is just an abstract development question. Anybody who wants to can get themselves on the agenda there. So we really try to do as much of our development as possible completely out in the open, make sure that we're having a conversation with each other. It's supposed to be a community project with community input, and community is everybody. It's users, it's developers, it's translators, so anybody who is interested in the project is welcome to show up at these things and have something to say. Sorry, Billy? Great.